In this video, I'm going to show you how to use your Sensory Percussion hardware or other drum trigger systems within Datanaught. But first, what is Sensory Percussion? Sensory Percussion is a software and hardware system that lets you turn acoustic drum sounds into controllers for electronic music making. In terms of sensors, any of these options will work. The version 2 sensor, which is the current sensor, works great. You just got to make sure you plug it into the portal. The version 1 sensor is a great option. You can just plug this directly into your interface and use phantom power. You can get these quite cheap used these days. Also, something like a D drum or a Roland drum trigger would work great. These have a contact mic within them. You can also even just use a contact mic directly and just attach it to your head with double-sided tape. And finally, you can use a 3D printed OP sensor, which is what I use for all the demonstrations. Whichever option you choose to use, they'll all work fine within Datanaught. Here we are inside of Max. An important consideration if you're using the Sensory Percussion 2 hardware is that the sensor input 1 will correspond with input 5 in Max, sensor 2 will be input 6, etc. So if you're plugged into sensor 1, you want to make sure that in Max you're using ADC 5 for your input. A good place to get started is to come to the Extras menu and go to Datanaught Overview. If you go to Use Cases, there's an option here for Sensory Percussion hardware. This will take you to all of the relevant objects that I'm going to show now, and it's just a good way of getting around the examples. So one of the things that you might be used to in the Sensory Percussion software is being able to hit different zones on the drum and have those correspond with different samples or different behaviors. Inside Datanaught and machine learning in general, we would call those classes. So that would be classification or training a classifier. There's a separate tutorial video if you want to look at that in some depth, but here's an example where I've got audio input coming in. So this is playing a snare drum, doing center, edge, rim tip, and rim shoulder, and that's mapped to kick, snare, and hi-hat sounds. Okay, so that's one of the core functionalities we're going to do. Now I'm going to give a quick overview crash course type thing of a bunch of the functionality that's most relevant if you're coming from a Sensory Percussion context. One of the things we want to get a strong understanding of is onset detection. So an onset is the start of a sound event in an audio signal. And we've got a bunch of things here. The main things are these macro parameters that we can control up here. And then these are some advanced settings. So if you want to tweak these, there's a webpage you can go and look at there. But here I've got some drum playing. I can see the vertical lines whenever an onset is detected. So here I have the same or very similar controls to what I have in Sensory Percussion. You've got sensitivity. So you can see this is moving two lines. We have the upper threshold and the lower threshold. So if I put this here, this will catch more onsets. You can see it kind of got that cluster of 3 there. And it does this by bringing the top threshold down and the lower threshold up. That means it's more likely to trigger an event. If I move this way, it's going to be less likely and it'll only catch the most prominent onsets. And you see it's missing some of those. Lockout is useful for setting the time in which an event can trigger again. So if I have some fast playing like I do over here, by default, it's set pretty short. So 30 milliseconds will let you do press rolls and buzz rolls and things like that. You can catch all of these events. If I make this bigger, so if I put this, let's say, to like 100 milliseconds or 160, it misses some of the fast ones. Depending on what you're playing that you're doing, that might be useful. So floor is similar to what you have in Sensory Percussion, where you can set a threshold below which nothing will be triggered at all. And as for the rest of these parameters here, there's a separate onset detection tutorial video that I recommend you look into. But just as a crash course, these are the main 3 parameters that we're going to be looking at. So once we understand onset detection, we can move on to classification. This is a core thing that we're doing that's very much like Sensory Percussion, where we give it examples of certain drum hits and give it a label and then train a classifier based on that. So here what I've got is some example training audio. So it's me playing the different zones, and then here's some like performance audio, playing a groove with those sounds. So in order to train a classifier, what I'm going to do is I'm going to enable training mode. I'm going to select the class that I'm playing, or the zone. So in this case, this is the center of the drum, and I'll play those hits. So when it gets to the edge, I'm going to change this over to edge. For all of these, you would do the same thing you would do when you're training in sensory percussion. You would want to do about 50 hits is good. You want to make sure you play at different dynamics, different speeds, basically a range of different timbres for each zone. Now, once I've hit all the hits that I need, I'll hit train, and that's done now. So it's made these classes for center, edge, rim, shoulder, and rim tip. So now when I play the example audio, you can see that it works. So some other things you might be used to if you're coming from sensory percussion is the idea of controllers. So within sensory percussion, you have a load of different controllers. Within Data, you have different kinds as well. So we have DK controllers, we have DK speed, and various other things. But to show these kind of briefly, so I'll play some audio into it. So what DK controllers does, it takes the loudness and the centroid and normalizes it between 0 and 1. In addition to giving you that value, it also gives you the average over a certain amount of hits, so in this case 7, the slope, whether it's going up or down, and the variance as to how varied it is. So you get all these additional bits of information based on the timbre and the loudness of your playing. So if I grab some kind of bit in the middle here. So I can see that the timbre has kind of jumped up and down, and that's affected the variance and the slope and the mean. You can see the loudness has been kind of the same, maybe going up a little bit, and you can see that in the slope is going up a little bit. So that's useful as a kind of secondary bit of information that you can use to then map onto something else. Now what DK speed does, the first parameter is very similar to the speed parameter we're used to in sensory percussion, but in addition to that, we get tempo, slope, and variance. And again, this is computed by default over 7 hits. So this is the time between hits. So this was kind of slow, then sped up a bit, and then slowed down for each subsequent hit. And that gives us this kind of curve here. So we have a fairly consistent tempo. The slope ended up being averaged out because it's moving up and down. And then the variance here is quite high. So depending on the audio that we play, you can get these interesting bits of information where based on the current speed and the rate that you're either speeding up or slowing down, you can use all of that to map onto a synth. So in this example here, I'm taking the speed thing. I'm using the control parameters of DK Mangrove and trigger individual notes based on the speed and the timing of my playing. Additionally, we have controller pitch. So this will let us map anything that's from 0 to 1. So in this case, I'm going to be taking the output of DK controllers. So loudness it'll be at this case, but it could be centroid, it could be pitch, it could be whatever we want as the input. And that's to be mapped to MIDI notes coming out. In this case, the higher the value, the higher it'll be within this specified range. And you can also specify a key and a scale. So if I put that together, so what I have here effectively is the louder I play, the higher a melody it's playing. And it's just going to move up and down based on these parameters there. And here we have the sampler, which has a lot of the same kind of features that you have in the sensory percussion sample playback unit. So we can set the start point, we can set the length, we can set whether there's a fade in or fade out. We can also set a curve for the fade in and the fade out, and combine all of these together. You can affect the playback speed, the amount of voices, the gain, etc. So it's a fairly full-featured sampler that we can use throughout Data Knot. Now the sampler you can use in various ways, and you can look at the help file for DK Sampler for more information, but we can trigger it based on just a number input. Or we can play back based on MIDI pitch input. So here I'm using controllers and controller pitch, similar to what I was showing it in that other example. So here I'm triggering the same sample over and over, but I'm changing the pitch based on the pitch from controller pitch in this case. So here I'm using audio descriptors to affect the sample that's being played back. So it's taking the loudness analysis of the incoming audio and using that to map to the loudness of the sample that's being played back. So depending on how loud that drum machine is, it affects the volume of the organ sample in this case. And then from there, we can move into more data, not specific things. So here we have this onset descriptors thing. What this is, it takes an onset, so your audio event, and then it analyzes various descriptors from that. So these are a bunch of the core descriptors that we have inside data not. For more information, you can look at the descriptors tutorial, but just to give a quick overview, what we have here is this descriptors one, which gives us a loudness, centroid, which corresponds to brightness, flatness, which corresponds to noisiness, and pitch. We have Mel bands, which is basically like an EQ curve. We have MFCCs, which describe a complex spectrum. So it's not exactly like the curves, but it gives us a summary of the timbre. We have sines, which gives us frequencies and gains. And then we have spectral shape, which gives us basically a more complicated version of this centroid and flatness. So you have the spread of the sound, the tilt of the sound. So all of these are being extracted from these drum hits. And you can use these to map things. You can use these to browse samples. You can use these to train classifiers, regressors. There's no shortage of things that we can do with these descriptors. And all of these are coming from onset-based descriptors. So for some more advanced things, we have input modes. All of the descriptors objects that I just showed and all of the analysis objects throughout have these various input modes. So what this lets you do is to tailor the analysis to the kind of input that you have. So the default is that you have a microphone going into the input and you're good to go. If you're using a Sensory Percussion sensor, either a version 1 or version 2, you would want to set the input mode to input mode 1. This will adjust the onset detection so that it'll work a little bit better with the sensors while keeping the audio analysis the same. And then input 2 is the same for contact mic based things, so conventional drum triggers or a contact mic. So these three will take just a single input, but then apply and improve the onset detection while leaving the audio analysis alone. Then for the rest of them, we have these combinations. So what this lets you do is if you have a setup where, like I often have on my drums, we'll have a Sensory Percussion or a similar type sensor going in, and then I'll have a separate microphone, so something like a DPA or something fancy that I want to use for the audio analysis. So this effectively gives me the best of both worlds, where I can use the onset detection from the Sensory Percussion while using the flatter, broader spectrum audio that I get from the DPA. So if I play a bit of audio here to give you an example. So for this first hit here, if I'm only using the Sensory Percussion sensor, you can see the centroid is quite high, as is the loudness. But in reality, if I take that same audio with the DPA, I can see the centroid is high, but not that high, and the loudness is a little bit lower. So this is here a bit more accurate as to what actually happened. So that's corresponding with this. So there's the same kind of idea, but if you're using a contact mic, this will take the audio from the piezo for the onset detection, but then use whatever microphone you want for the audio analysis. This is the same kind of idea where we're having one mic for onset and one mic for analysis, where here if you want to apply your own compression or an expander, an EQ or filter, you can apply that yourself. And finally, there's a Sensory Percussion specific mode that takes single audio input, and what it does, it takes the onset detection from the Sensory Percussion, and then it applies microphone correction to the audio of the Sensory Percussion to give you a bit more of a realistic sound of what a microphone would sound like. So another thing that we can do here is apply mic correction. So the audio coming from a Sensory Percussion sensor, either the version 1 or 2, is not very good quality audio, as in it doesn't sound good. So for example, here's the raw audio coming from a Sensory Percussion 1 sensor. Doesn't sound great. It works actually quite well for classification, but in terms of raw audio, if you wanted to use that to apply effects to, it doesn't sound very good. So what I can do here is I can use convolution with, in this case, it's an impulse response that's correcting the sound of a Sensory Percussion sensor to try to make it sound like an Earthworks microphone. And I can apply that to the sound, and then after doing that, I get this. Which, I would still use a microphone if you have the luxury for that. But in terms of using it for audio processing, if you run it through the convolution, you can actually get a usable sound from the Sensory Percussion sensor itself, which is great if you want to apply effects to your snare without having any bleed from the overheads or anything else. And finally, combining the classification with descriptors, we have class descriptors, class mel bands, class spectral shape, class MFCCs, etc. It'll do the same classification that it's been doing, but it'll also give you additional descriptors for any specific class. So in this case, I've got some beatboxing here. So it tells me the class that's happened, and then it gives me the corresponding descriptors for that class, which is quite handy if you want to take the kick sounds from, in this case, the beatboxer, and I want to take the descriptors from only the kick ones and use that to map to something else. I have those that I can then do that with, and the same with the snare and the hat. So there we go. That's showing you how to use the Sensory Percussion hardware within Datanaught.